Pneumatic conveying and exhaust systems. Many stocks in the milling process are pneumatically conveyed from one point to another. Additionally, many machines in a mill need to be exhausted by air to achieve their function. In this chapter, you will learn about pneumatic system components, exhaust systems, filters, negative pressure pneumatic conveying, and positive pressure pneumatic conveying. Pneumatic systems. Pneumatic systems have three main parts: air movers, fans or blowers, piping or duct work to channel the air, and a device to filter the solids from the air, usually a cyclone or dust collector. Exhaust systems. An example of the use of an exhaust system is the aspiration of a wheat elevator. A wheat elevator may be exhausted by a pneumatic system to prevent the buildup of dust. A fan connected to a dust collector moves the dusty air. Ducting directs this air from the elevator to the dust collector. The ducting is wide, therefore the airspeed is slow. Since only a small amount of light dust particles should be present, the slow airspeed should be enough to carry these particles. The dust collector filters out solid dust particles from the airstream before exhausting the cleaned air to the atmosphere. In this example, the airspeed is controlled by the ducting diameter, the fan strength, and any baffles or valves within the ducting system that can create a partial barrier to the air current. Filters. Devices for filtering solids from the air come in various forms. Cyclones are the simplest. They can be small or large. The principle in both cases is the same. The airstream and the solids in that airstream enter the cyclone at a tangent. The tangential motion causes solids to spin around the internal walls of the cyclone. The air entering a cyclone also spins but is unable to pass out of the bottom of the cyclone and exits upwards into the manifold. The air entering a cyclone slows, allowing solids to slow down and drop under the influence of gravity. Eventually, the solids exit through a rotary seal. Rotary seals are used to transfer solids between areas at different pressure. The inside of a cyclone is either under negative or positive pressure, depending on the system requirements. In each case, the rotary seal creates an airlock preventing air from travelling in or out of the cyclone from the bottom. The rotary seal consists of a shaft with vanes which span the outlet to create this airlock. The shaft rotates to allow solids to drop through from above. When large cyclones are used as filters, they may also contain fabric filter sleeves to improve dust extraction. For example, this dust collector is used as part of the exhaust system for a small screen room. It filters the dusty air exhausted from screen room machinery and elevators. Other types of filters rely much more on fabric filter sleeves to separate the solids. The filters are usually cleaned by a system that intermittently blasts compressed air into each filter. The blast may only last a fraction of a second and only clean one row of filters at a time. Despite the automatic cleaning, the filter still needs to be cleaned or replaced periodically to allow air to keep flowing. If the filters get too clogged, the pressure drop across the sleeves increases, resulting in the fan motor having to work harder to keep drawing air through, which may result in overheating. As a rule of thumb, the pressure drop should not exceed 170 millimeters of water. Filter sleeves should be replaced when the pressure drop across the sleeves exceeds the manufacturer's recommendations. Negative pressure pneumatic conveying. Another example of an exhaust system is the negative pressure pneumatic system. That exhausts from beneath a collection of grinding machines called roller mills. This system conveys milled stocks to the top floor of the mill and has two sets of fans. There is a main fan to which all the pickup lines are connected. This fan moves air up through the pickups into the manifold and out to the dust collector. Another fan is also connected to the dust collector, drawing air through the filters and out into the atmosphere. There are both pipes and ducts to channel the air. Where pipes are used for conveying stocks, the air speeds need to be fast enough to carry the solids. Therefore, narrow pipes are used. Small cyclones separate most of the particles from the air and function as small filters. Pipes channel air and stock from each roller mill up to the cyclones at the top of the mill. These cyclones filter the stock from the air so that the stocks drop back down into the mill system while only relatively clean air enters the central manifold. Fans and baffles help control airspeed. There is a baffle immediately upstream of the main fan to control the overall airflow rate. There are also baffles immediately downstream of each cyclone to control the air strength for each pickup. These baffles are adjusted so that the air current is strong enough to pick up the stock, but not so strong that the stock is sucked into the manifold. The stocks can be seen spiralling downwards in the sight glasses. Excessive spiralling suggests that too much air is being used. Some systems automatically adjust baffles to ensure that the suction provided by the main fan is correctly distributed to each pickup, and self-adjust if the stock levels change over time. Positive pressure pneumatic conveying. Unlike negative pressure systems, which tend to collect air streams from multiple points, positive pressure systems tend to convey stock from a single point to another single point, or perhaps a few possible points, but only one point at a time. For example, a positive pressure system can convey flour from a collection conveyor to one flour bin within a nest of possible flour bins. In positive pressure systems, the air mover is at the beginning of the system, and the air pressures generated by the air movers, called blowers, are usually much higher than for negative systems. The higher pressures allow higher throughput rates, and stocks can be conveyed much further. The input stock cannot be sucked into the system but must be dropped into the conveying pipe through a blow-through type rotary seal. These seals carry the stocks into the blow lines without allowing the air out. This chapter has covered the basics of pneumatic systems, exhaust systems, filters, negative pressure pneumatic conveying, and positive pressure pneumatic conveying. The quiz that follows will help you to confirm your knowledge.